Now, if you printed out the notes for these, and the notes are in Shobi, and I think they're also in D2L, but I know for sure they're in Shobi. If you print out the notes for these, a lot of this, you don't really need to write anything down because I put all of what's on these first few slides in the notes. This is just, I'm going to paraphrase the explanation. How many people in here have had anything, how many people have had your economics class? Those of you that have had economics, have you talked about elasticity? Okay, tell me what you know about elasticity. What does it mean if your demand is inelastic?
It's not going to move very easily.
Okay, so small changes in, let's see, demand depends on what two things? Price and quantity. So it says that the number sold, if it's inelastic, the number sold is not going to change much based on changes in the price, right? And elastic means that the price has a lot of influence on how many you're going to sell. If the price goes too high, you're probably going to sell fewer. If the price goes too low, you're going to sell more. Okay? What do you think unit elasticity means? One of them says one doesn't affect the other one very much. The other one says one affects the other a lot. What about if it's what's called unit elasticity? Changes in neither one changes. You know, no change in one equals no change in the other, but small change could cause equally small changes or equal changes. In this particular case, we're going to talk about elasticity of demand. And as you know, price affects demand, but price isn't the only thing that affects demand. Elasticity of demand is based upon the fact that there are some things you have to have regardless of the price, right? I mean, you're going to have to buy bread, you're going to have to buy groceries, you're going to have to buy milk. If you're sick, you have to go to the doctor, you're going to have to buy medicine. But you don't have to buy a new car, and you don't have to eat out, and you don't have to take a cruise. You don't have to buy jewelry. So the need for the product affects that too. And that's where there's something called E comes in. E will measure whether the demand is elastic or inelastic. And eventually, if you can get unit elasticity, that's where the revenue for the company is actually going to be maximized because they're going to get the most revenue for selling a particular number. And if they raise the amount they're charging, their revenue is not going to increase very much because the demand's going to drop. And if they lower the price, the revenue is still not going to change very much because the demand is going to go up. So even though they're getting less, they're selling more. So that means you have kind of like that sweet spot that people want for revenue. And as this says, luxury items tend to be more sensitive to price than essentials. So milk, heating fuel, light bulbs, relatively small percentage changes in the price aren't really going to make much difference in how much people are willing to buy. In other words, your quantity that's demanded. Whereas cars, home loans, jewelry, and concert tickets, small changes in the price can cause a big change in whether or not people are going to buy it, and the number then that you would sell. One of the ways that we measure elasticity of demand is to measure the sensitivity of demand to changes in price looking at relative change. So the numerator of this is actually the difference in Q divided by P. In other words, that's a rate of change. It's the rate of change in how many are sold as a function of price. And then the bottom part of this ratio is the change in price based on price. Now, when delta Q represents the change in Q and delta P represents the change in P, that ratio is always going to be negative because P and Q are, let's see, quantity and price, they're both positive. But the change in Q and the change in P will always have opposite signs. If demand goes up, what happens to the price?
Goes up.
And if demand goes down, what happens to the price? Or maybe we could think about it in opposite terms. If the price goes up, what happens to demand?
Down.
Down. And if the price goes down, what happens to demand?
That's good. Up.
It's going to go up. Okay? So they're always going to have opposite signs. They're an inverse relationship. And basically, that, if you think about it in English, that means an increase in price causes a decrease in demand and vice versa. So the absolute value of that, if the absolute value of that ratio is large, what it suggests is that a relatively small increase in price can cause a relatively large drop or decrease in your demand. Now, and don't worry about making notes on all this, just try to follow along, and I'll try to clarify algebra as we need to. Basically, if we split this up, the top part of that ratio is the change in Q divided by Q. And the bottom part of that, since it's being divided, you're going to take its reciprocal and multiply. When you take its reciprocal and multiply, then you've got P over the change in P. And if you'll just rearrange that a little bit, that actually comes out to be P over Q times the difference in Q based upon the difference in price. And eventually, this all goes through the idea that dQ over dP or delta Q over delta P is a slope formula. It's the change in, it's F of P plus the change in P minus F of P because Q is a function of P. And then on the bottom, you're going to subtract to get the difference in the price. And as that difference in price becomes zero, this is going back to chapter 11, when the limit approaches zero, then what actually happens is that this becomes the derivative of quantity with respect to price. So dQ dP is the derivative of quantity, or the rate of change in quantity, based upon a unit change of price. Now, one thing that's very important that you notice, and I'm going to slide over, see if I can find a piece of paper, because the notation can get confusing, and I know it can. So I want to emphasize something to you in this. There's a lot of different ways to say dQ dP. Okay? Every single, don't do that to me. I think we went through this yesterday. This thing is so conflicted.
It's not working. It's not working.
yourself.
It's very important that you remember that all those symbols at the very top mean exactly the same thing. Okay? The fact that dq over dp is the same as d over dp throws some people for a loop. But it is the same thing. Okay? They do that all the time. They'll leave out the function name and just tell you what it's with respect to. But those are the same. And when you're doing some of these problems, especially when I go into what we call implicit differentiation, sometimes I will substitute q prime in place of dq dp, just because it takes less time to write q prime than it does to write dq dp. Okay? But those all mean the same thing, and they all mean the rate of change in quantity with respect to or per unit of change in P. Okay? Q being quantity, P being price. Quantity demanded. So the negative, once we actually finish out all the calculus and the limits for that problem, the negative of that last quantity is called the elasticity of demand, and it measures the instantaneous responsiveness to demand to price. So at a certain price, it will tell you what the demand is doing. Is it increasing? Is it decreasing? And by how much? Okay? So, elasticity of demand, and here I'm going to give you some equivalent ways to look at this. So with equivalent notation, one of them shorthand, one is actually what's in the book. Elasticity is the opposite of the ratio of P and Q, specifically when P is on top, times the derivative of Q with respect to P. So basically, it is the opposite of P to Q times the derivative of Q. That's what demand actually, that's what elasticity actually is. And the key idea here is what happens when elasticity is less than 1, greater than 1, or when is it 1? Now, less than 1 means either it's a fraction or negative. A decimal less than 1.0 or negative. Greater than 1 means it's 1, 2, 3, 4, 5 on it, however big you might want to make it. It's not just positive, it has to be more than 1. And then E equals 1 is what we call unit elasticity. When E is less than 1, demand is what we call inelastic, and I'll explain what that means in a second. When E is greater than 1, then demand is elastic, and when E is equal to 1, demand has what's called unit elasticity, and that actually turns out to be a very important idea. I'm trying to find my example here. Now, before we talk too much more about that, E has an estimated value of 0.6 for physician services. Okay, now 0.6, is demand elastic or inelastic if it's 0.6? It's inelastic. So on the condition of physician services, what that means is that the demand for medical care doesn't much depend on price. Okay? If you gotta have it, you gotta have it. You're gonna pay what they want you to pay, up to a point. Okay? Now, elasticity is 2.3 for a restaurant meal. What does that mean? Demand is elastic, right? It means that if the restaurant meal costs too much, you're probably not going to buy it because the restaurant meal is not a necessity. You know, you can look at how much money you've got and say, okay, here's my choices. I've got enough money to go buy some food at the grocery store and make a nice dinner, or you know, I could go to a restaurant, but I'm not going to be able to go to a nice restaurant and eat well. I'm going to have to go to my McDonald's and spend my money, so I'd rather eat healthier and go home. So you know, if the price is too high, you're not going to go eat out at the restaurant. You're going to eat at home. Okay? So if E's -1, the relative change in demand is less than the relative change in price, and that's what's called inelasticity. And if it's greater than 1, then the relative change in price causes an even bigger change in the demand, and it could be up or down. Okay, one could cause the other to go up or down. It's the amount of change we're looking at. You know, if the restaurant meal's on sale for, you know, buy one, get one free, well, okay, that's a lower price, and that might make you more inclined to spend the money on the restaurant meal. Just because the doctor says, well, I charge twice as much as this guy, that doesn't mean you're going to go to that doctor. You're probably going to go to the less expensive doctor if you know he's still good, unless, you know, it turns out that the other guy's a specialist, and then it's worth it to you to pay more for him. So basically, in English, inelastic means a small change in price has little effect on demand. And elastic means that a small change in price has a big effect on demand. And when elasticity is equal to 1, that means that the percentages in price and demand really kind of balance each other out. If one's small, then the other is a small change. If one's large, the other one is a large change. But they kind of go hand in hand. And that's when we have unit elasticity. Now here's our example problem. Terence Wales described the demand for distilled spirits, alcohol, as Q is equal to F of P, a function of price, And that function of price is negative 0.00375p plus 7.87. What kind of a function is f of p? Linear, quadratic, rational, radical? What kind of a function is f of p? And how do you know? My finite class would have already answered me here because they like these functions. They're easy.
Linear.
It's a linear function. Linear functions are easy to solve. You can solve them in most 2 steps. So, how hard is it to take the derivative of a linear function? Not hard at all, because the constant becomes 0, and the slope of that line, which is the number in front of the variable, is what the slope is. So f prime of p in this case is negative 0.00375. In other words, dq dp is negative 0.00375. We know what dq dp is. P represents the retail price of a case of liquor in dollars per case. Q is the average number of cases purchased by a consumer each year. So per year, per consumer. Calculate and interpret the elasticity of demand when the price is $118.30. So all you do is you know the expression for Q. You plug that into your elasticity equation for Q. So here's your elasticity equation. E is the opposite of P over Q times the derivative of Q. So P is just P. Q is a function of P, so Q is negative 0.00375p plus 7.87. The derivative of Q is the 0.00375. So the elasticity is 0.00375 times P over negative 0.00375p plus 7.87. The reason this is positive is because this ratio is negative and the derivative is negative, and negative times negative is positive. Any questions on where that function came from? We just plugged in what we were given into the formula for elasticity. Everybody okay there? Now, what else did they ask us? It says calculate and interpret the elasticity of demand when the price is $118.30 a case. So what we're going to take, I'm going to move over here and do some of this by hand so y'all can keep up better. I'm also going to swap notations on you so that you realize it really is the same. So E is equal to the price P, and it's negative out here. times the negative 0.00375 P plus 7.87 times the derivative of P, or F prime of P, I'm sorry, the derivative of Q, which is F prime of P, is just the constant in front of the P. So when we multiply it all out, E is equal to negative times negative is positive P over negative 0.00375 times P plus 7.87. And then what they actually ask us to find was find the value of E when the price is $118.30 a case. So in place of P, we're simply going to plug in 118.30. And then we'll grab a calculator. Help us out with the arithmetic. So what's 15.93? Y'all double check my arithmetic, make sure I didn't miss enter anything. Are we good?
Numerator is going to be P times negative 0.00375, right? Not just the 118.30.
Oh, yes. Thank you. That's why I said y'all double check my arithmetic. I totally left off the derivative. So let me go back and modify that. Thank you, Keith. Yeah, it's going to do that right. So it turns out to be, and that makes much more sense, because this was elastic and it shouldn't have been. So E equals negative 0.0597. Which means E is less than 1. And that means then that demand is inelastic. And And when it's inelastic, that means small changes in price will make relatively large changes in demand. Does that make sense?
When you ask us to interpret it, do we need to put if it's elastic or inelastic, and then
Explain.
the next part?
Yeah, then explain what that means in context. And I didn't put it in context of liquor, but basically what it's saying is that if the price of the liquor, because demand is inelastic, and again, you're always going to have to go back to that definition, that's what I covered up. About what happens when demand is inelastic, and then translate it into what does that actually mean about the price of distilled spirits. Does a small change in price make a big change? And if you think about it, it does. Because spirits is one of those things that's, you know, people are not, they consider that a luxury for the most part. So they're going to buy it when it's on sale if they want it, and if it's, the price on it goes too high, they're going to buy less of it for the most part.
I'm also trying because I'm just trying to
Okay?
I'm struggling. I'm struggling.
So since the, and notice, I got negative, I'm not sure how I got negative, because this would have been negative over negative, that should have been positive. Let me go back and look at my calculator a second. Make sure I didn't mess something up.
The 118 should have been negative in the numerator.
Okay, that's why. And a negative times a negative makes that positive. But it still comes out, it changes the number. 0.05 is actually what you probably rounded to, or 0.06. But the fact is, what they're looking for is the fact that it's less than 1, which makes it inelastic. And since it's inelastic, a percentage change in price will result in a smaller percentage change in demand. The demand is less responsive to the price. So if you increase the price, then that will also increase your revenue, because changes in price don't really have much result in the change for demand. So that means if you had a 10% increase in price, the approximate decrease in the demand is going to only be about 0.6%. It's going to be very small. You can find the decrease by multiplying the percentage of increase or decrease in price to find the increase or decrease in your demand. Okay? Now we've got a second example. This one's about beer. Must have got someone's attention. The demand for beer was modeled by Hogarty and Elzinga with the function given Q is equal to F of P, which is 1 over P. So in other words, the quantity purchased is inversely related to the price. The price is expressed in dollars per can of beer, and the quantity sold is in cans per day per adult. Calculate and interpret the elasticity of demand. Okay, elasticity of demand is what? I'm going to write it on here while you think about it. So since Q is 1 over P, the first thing we're going to need is dQ dt. Or in other words, Q prime. And since Q is 1 over P, then Q is the same as P to the negative 1 power, right? So if it's P to the negative 1 power, I'll flip back and forth here. F of P is P to the negative 1, so the derivative of F of P, which is dQ dP, is negative 1P to the negative 2, which they wrote as negative 1 over P squared. And that actually might be a little easier since we're plugging that into another formula, and that's not a hard change to make. So you could use either one of those that you want to, but then that means that elasticity E, since Q is 1 over P, we have that. Opposite of P over Q, which is 1 over P, times the derivative, and I left out my negative sign, is negative 1 over P squared. Now, this is ugly. We know that's ugly. But bear with me, it's going to become unugly. Negative P times negative 1 is what? I should have heard everybody in here say the answer.
P.
Say again?
P.
Just plain old P. Now, there's a couple of ways to do this, but here's the easy way. A fraction times a fraction means you multiply straight across. 1 times P squared is P squared, P times 1 is P. So the denominator is equivalent to P squared over P. Can you reduce that? And if you can, what is it? P. And what is P over P? It's equal to 1. What does that mean about elasticity?
Unit elastic.
Okay, it has unit elasticity. What does that mean in terms of the price of a can of beer? That's what we really want to know, is what does it mean in terms of the can of a price of beer? And remember, price has to be positive, so we're not talking about negative price. Since price has to be positive, what you see is that revenues are going to remain constant because a change in price has little influence on a change in demand. They're going to buy it no matter what happens to the price, as long as the change in price isn't too huge. I'm not sure they'll pay $15 a can, but if they make a small percentage increase in the change of the beer, it's not going to change the price, the quantity that they sell. Quantity may go up a little or down a little, but not by much. So the point here is we want to talk about total revenue and elasticity. Because remember, revenue is based on the same thing that demand is based on. How many you sell and what was the price for selling it, right? So, if you take, why did you keep Okay, I'll give it a minute to catch its mind again because I'm gonna need it for something else in a little bit. We finish this up with PowerPoint. What happens, and all that shows you on there, and I don't want you to write that down. I think I actually even put that in your notes instead of having you write it down. In English, what this means is that when you do all the algebra where you take the derivative of revenue with respect to P, you get the price times the derivative of the revenue plus the revenue times 1 because the derivative of P is 1. It's the independent variable. And since Q times 1 is just Q over Q times P plus the derivative plus Q can all be manipulated down once you realize that what you've got here is the elasticity. All modifies to the fact that Q is equal to 1 minus E. Okay? Now here's the upshot of that, and that's the part in red. I don't expect you to go through the algebraic derivation. The point is in English that total revenue is increasing, optimized, or decreasing depending upon whether the derivative is positive, 0, or negative. And that corresponds to when E, the elasticity, is positive, unit elasticity, or negative. And the real upshot of that is that it is optimized when the elasticity equals 1. So everybody likes unit elasticity because that's where people make the most money and generally get the best deals. You're going to buy regardless of the price because if the price goes up a little, then you don't really care. If it goes down a little, you really don't care. And neither does the supplier because if you buy a few more at a lower price, he still makes the same revenue as if you bought a few less at a higher price. So everybody's happy when E is equal to 1. This is an important page. Make a note of this. Put a star by it. Highlight the box because you need to know this. The demand is inelastic. Total revenue will increase as the price increases. Then that's because small changes in the price make big changes in the demand. If the demand is if it was inelastic. If the demand is elastic, your total revenue decreases as the price increases. And that's because when the price increases, your demand drops down. Therefore, your revenue is going to drop down. But your total revenue is maximized when demand has unit elasticity, so that's very, very important. How many people in here had problem stats? I know some of you have. What's that picture look like? Does it remind you of? Do you remember what it looks like? What kind of curve does that look like? A normal curve or a bell curve? Where do you find the maximum? In a bell curve, the mean, median, and mode, mode being the thing that is the maximum, shows up the most often, are in the middle. So you maximize revenue when E is equal to 1. And you have inelastic demand when it's less than 1, and elastic demand when it's greater than 1. Okay? And this is basically because E and the derivative of R have opposite signs. So here's our last example. At least for the time being. Assume that the demand for a product is Q is equal to 216 minus 2P squared, and P is the price in dollars. Find the price intervals where the demand is inelastic, and find where the demand is elastic, and what price results in the maximum revenue, and what is the maximum revenue. Now, if you think back into chapter 13, this is not a whole lot different from what we did in chapter 13, where we would take a function, take its derivative, find the critical numbers of the derivative, and test to see if the derivative was positive or negative on either side of those critical numbers to determine if the function was increasing or the function was decreasing, or in this case, whether revenue is or elasticity is less than 1 or more than 1. Okay, so it's a similar process. So the first thing we need to do is we need to take the derivative of Q. The derivative of Q, derivative of 216 is 0. The derivative of negative 2P squared is negative 4P. So dQ dP is negative 4P. We do exactly what we did a minute ago. We leave P in there because we're going to have to be given a price, or we're going to have to hunt for one. Divided by the quantity, Q, and Q is a function of price, so Q is 216 minus 2P squared. And then times the derivative of negative 4P. And since negative times negative is positive, the numerator is 4P squared over the denominator 216 minus 2P squared. Anybody have any questions about how we got there? Okay, we want to set E equals to 1. That means that fraction we just got gets set equal to 1. How is the only way you ever have a fraction that is equal to 1? What does that require? Is 3 over 3 equal to 1? Is 2x squared over 2x squared equal to 1? Is 5x minus 9 over 5x minus 9 equal to 1? So what's required of the value of the numerator and denominator for the value of the fraction to be 1?
They have to be the same.
They have to be the same. They have to be equal, right? So what you do is you just, in order for this to happen, you know that the numerator and denominator have to be equal. So set them equal to each other and then solve. And when you solve this, it turns out we have 6P squared equals 216, and eventually P is equal to 6. So E is going to be equal to 1 when the price is 6. That's what that means. E is going to be equal to 1 when the price is 6. And then all you have to do is plug into the formula for E, plug in a number that's less than 6. Lazy people like me like 1. It's easy to plug in. 4 times the 1 squared over 216 minus 2 times the 1 squared is 4 over 214. And I don't care what 2 over 14 is. I don't care if we reduce it. Is it positive or is it negative? Or is it a fraction or is it something more than 1? Is it less than 1 or more than 1? It's less than 1. When you plug in 10, because 10 is definitely more than 6, it's 400 over 216 minus 200, which turns out to be 400 over 16. Is that more than 1 or less than 1? More than 1. So the demand is inelastic when P is less than 6, and the demand is elastic when P is greater than 6. And you have unit elasticity when the price is 6, which means everybody's happy when the price is 6. Okay? And then it says what price results in the maximum revenue? 6. That's the whole point of finding out where E was equal to 1 and P was equal to 6. So the maximum revenue is 216 minus 2 times 6 squared, which is 144. And since your revenue is actually price times the quantity, then the quantity is 144 and the price is 6. So your maximum revenue is $864. Are we good? Now, this is where I pick up on Thursday. There are only 2 examples in implicit differentiation, but I've had people in my night class, because they're a little ahead of you, say, you know, your 2 examples were great, I understood them perfectly, but when I try to do the other problems on my own, I get confused. Can you post some more examples? What I'm going to do is I'll go through the 2 examples in the PowerPoint with you on Thursday, and then I'm going to record some more that are similar to the Show Me homework, and the ones that are in my math lab. I'll record some more with those little short videos that I put in Show Me and put them on the 14.4 Show Me homework. On Thursday, you need to be here on Thursday. Anybody planning not to be here on Thursday? You have a take-home test over chapter 12, 13, and 14, and it will be due back on Tuesday. We're going to put 12 on this one too, because you still need to know how to take derivatives. Okay? Now, here's one thing I'm going to tell you in advance. I'm going to warn you. On the test, the one thing people are still tripping up on, not everybody, but some people, is finding marginal, average, profit, cost, revenue, demand, whatever. You need to go back and review what it means to have marginal, average, cost, revenue, profit. Average means divide the function by x. Marginal average means divide the function by x, or multiply it by 1 over x if it's easier, and then take the derivative. Don't take the derivative and then divide it by the value. That's backwards. Make sure you do the steps in the right order. I will try to do another example for you, plus I recorded an extra example of marginal average cost to post for you. Because I know everybody's still having trouble with that. See you Thursday.